let's discover and find a pattern for how to simplify radicals with odd exponents. We already have a pattern for taking the square root of all of the other types of exponents, whether it's even, where really what we're doing, based on the pattern, is taking half of the original exponent, because that's how many pairs of x's are going to be there. So if we have x to the 6th power, we know we're going to have 3 pairs of root x's. So the square root of x to the 6th is x cubed. The square root of x to the 4th is x squared, and the square root of x squared is just x, or x to the 1st power, if you will. But what about the square root of x cubed? We can't do half of 3 and get a nice integer. We can't do half of 5, half of 7, and so on and so forth. So let's break it down the more formal way, like we did originally with the even exponents before we knew the pattern. So x cubed is exactly equivalent to 3 of these root x's multiplied together. Root x times root x times root x. Now, we know that we are looking for pairs of exponents. Sorry. We are looking for pairs of exponents, or pairs of root x's, sorry. So here is a pair of root x's. We know that that is going to simplify to just normal x. You can't take the square root of a normal x, though, so we have to leave that normal root x there. So I'm just going to have x root x. And there you go. It looks kind of strange, I'll admit, to have both an x and a square root x there, but you'll deal with it so many times that it's going to become kind of second nature to you. What about x to the 5th power? We have 5 of those root x's. 1, 2, 3, 4, and 5. Okay. Again, we are looking for pairs of root x's. So there is 1 right there. There is a second pair of root x's. So since we have 2 pairs of root x's, that is going to get us x squared in the end. And yes, we still have that odd man out, that lone root x. But all together, both the x squared and the root x is our answer. Is there a pattern here? Absolutely. You'll notice that with both of these odd examples so far, we have this odd x left out. Okay? Odd x left out. There's just one random x that has nobody to pair with. And that makes sense because we have an odd amount of x's, so we can't complete all of our pairs. There's going to be just one and only one ever left over with odd exponents. So let me write this out a different way, because writing out 7 or 9 or 11 root x's is going to get pretty tedious. Let's just say, since we know that we're going to have only one odd x left out, well, the other 6 will have somebody to pair with. Then there will be an odd x left out. But we know what the square root of x to the 6th is. We know that from here. We take half of it. So that is going to give us x to the 3rd power and then we have the lone root x left over, the odd man out, okay? Keep the pattern going. That's going to be root 8 times root x, root x to the 8th times root x. And half of 8 is 4, so we'll have x to the 4th power here times root x. And I will leave you on your own to do the x to the 11th, the square root of x to the 11th. In summary, to take the square root of an even exponent, you take half of the exponent and remove the square root sign. Don't leave that square root there for for even exponents. Don't leave any radical sign there. But for odd exponents, you're going to break down the odd exponent into its highest even component and the one odd man out, the leftovers. That leftovers is going to stay underneath of the square root sign, but the even components you are going to take half of and remove the radical sign.